Hey everyone, and welcome to today's Explainer. I'm honestly so incredibly excited to guide you through this one because we are looking at something that literally changed the entire landscape of software development. You know, if you've ever even thought about creating a mobile app, you've probably figured out pretty quickly that building for an iPhone and building for Android, well, it usually means doing the exact same work twice. But what if it didn't have to be that way? Today, we are exploring the core value proposition of React Native. Basically, it's the absolute magic of getting 3 apps for the price of 1. We're going to lift the hood and unpack exactly how this framework lets developers write in JavaScript and React and somehow end up with fully functioning apps for iOS, Android, and the web, all from just one single codebase. Okay, let's dive into this by looking at a pretty famous principle in the programming world, Atwood's Law. Now, this law famously states that any application that can be written in JavaScript will eventually be written in JavaScript. And honestly, this is the inevitable force driving the whole evolution of mobile development. I mean, think about it. JavaScript started out as this super simple scripting language just to make web pages, a little bit interactive. But developers ended up loving it so much, and the ecosystem grew so incredibly vast, that people naturally just started asking, hey, why can't we use this completely ubiquitous language to build our mobile applications too? Atwood's Law basically predicted the very existence of tools like React Native, pushing JavaScript way, way beyond the traditional web browser.
Section 1. JavaScript's Mobile Takeover.
Right, so when developers first tried to use JavaScript for mobile, the transition was, well, it was rough. We went through this entire era of mobile app building where developers were essentially just trying to force web code onto phones, and they did it using these 3, honestly, kind of clunky steps. Step 1, you'd build a standard web application. Step 2, you'd wrap that web app inside a sandboxed browser, which was known as a WebView, and then Step 3, you'd deploy this wrapped-up website to the app stores using the specific tools of the trade at the time, like Apache Cordova or Adobe PhoneGap.
But this clever little workaround had a fatal flaw. We call it the WebView problem. Basically, it is incredibly hard to make a website actually feel like a true native experience. When a user downloads an app, they expect a certain level of smoothness, right? Because these early apps were literally just websites running in a hidden browser, they often felt like you were dragging a heavy anchor. Buttons lagged, animations stuttered, and the user experience, it just really wasn't there.
Section 2. A new philosophy.
Now, what's really interesting here is this massive paradigm shift. The industry finally realized that wrapping websites in invisible browsers just wasn't going to cut it for premium, high-quality apps. See, the old WebView approach operated under this philosophy of write once, run anywhere, basically forcing web code where it didn't really belong, even if it felt totally clunky. React Native flips that completely on its head to learn once, write anywhere. You aren't just copy-pasting a website onto a phone anymore. Instead, you take the core concepts, the structures, and the language you already learned for the web, and you apply those exact same mental models to write highly specific, optimized code for any platform.
To be perfectly clear, you can't just literally copy-paste a web app to the App Store. But you can use the React skills that are already hardwired into your brain to build a native app. And you get to do this completely bypassing the incredibly steep learning curves of languages like Java or Objective-C. You're simply recycling your existing knowledge.
Which brings us to the absolute business magic of this framework. The number 3. By leveraging that learn once, write anywhere philosophy, a single team of developers can output an iOS application, an Android application, and a web application, all stemming from one single unified codebase. You are quite literally getting 3 distinct, incredibly powerful platforms for the development cost and effort of just one.
Section 3. How it works. So how does it actually avoid that old WebView problem and manage to generate these distinct apps? Well, the key difference is all about your building blocks. When you're building a website with regular React, you use HTML. But React Native, while it feels exactly like building for the web, you actually throw standard HTML completely out the window. Instead, you import fundamental components provided right by the framework itself. We're talking things like button, switch, scroll view, and a foundational view component.
So the crucial point is exactly how this translates at runtime. Let's trace it. When you write a generic view component in your React Native JavaScript code, the framework acts like a real-time translator. On an Apple device, it translates that generic view into a true native view. On a Google device, it dynamically translates it into an Android.view. And if you're targeting the web, it becomes your standard HTML div. You write the component once, and React Native dynamically renders the authentic, true native UI element for that specific platform. This is exactly why it doesn't feel like a clunky website. It's rendering the exact same native visual elements as an app written natively in Java or Objective-C.
But, what if you don't want everything to look exactly identical across all devices? Sometimes an iPhone user expects a certain type of swipe menu, while an Android user expects something completely different. Well, React Native handles this beautifully through the Platform module. This handy feature allows your code to check the current operating system on the fly and render completely different visual components based on that check. It ensures your app feels perfectly tailored to the exact device holding it.
Now, we definitely need to talk about paint and polish. On the web, styling is dictated by CSS, right? Well, in React Native, CSS doesn't exist, literally none. Instead, every single core component takes what's called a style prop. You customize all the visuals, like your colors, padding, the layout, by constructing a style sheet directly out of JavaScript. It's definitely a slight mental shift for web developers at first, but it keeps all the styling logic neatly contained right within the JavaScript ecosystem.
And oh man, speaking of developer experience, we absolutely have to talk about a literal time-saving superpower: fast refresh. You tweak a color, you adjust a layout, and boom, it instantly reflects on your screen across any platform right during development. There is absolutely no agonizing waiting for the entire application to recompile and reboot just to see if you moved a title over by 2 pixels. It makes the whole building process incredibly fast and highly interactive.
Let's move on and see how this all builds together into physical hardware. Section 4. The native ecosystem. Because let's be real, a good app isn't just about pretty buttons. It's about interacting with the physical hardware. Modern apps need to tap into powerful native device features to actually be useful. We're talking about accessing the physical device camera, sending complex push notifications right to a user's lock screen, or tracking real-time geolocation. React Native effortlessly bridges your JavaScript code over to command all of these physical hardware features.
And the main reason this bridge to the hardware works so seamlessly is actually because of the people behind it. These complex native concerns, like, figuring out exactly how to make JavaScript talk to a specific Android camera lens, those are handled by one of the most active open source communities on all of GitHub. Developers from all over the world are just constantly writing, updating, and sharing the code needed to make these complex device features easily accessible to everyone else using the framework.
Because of this massive, vibrant community, the ecosystem tooling is incredibly robust. I mean, if you need your app to do almost anything, there is very likely an open source package for it that you can easily install using NPM, exactly like you would in any standard JavaScript project. Furthermore, there are entire frameworks like Expo built right on top of React Native. Expo provides literally all the heavy lifting production tooling you could possibly require to actually compile, build, and ship your finished apps straight out to the app stores. Another really vital takeaway here is that React Native is highly flexible. It is absolutely not an all-or-nothing solution. I mean, you certainly can use it to build a complete mobile app entirely from scratch. But let's say a company already has a massive legacy app written entirely natively in iOS and Android. They can seamlessly integrate React Native just to render a single new screen or a single new feature to save development time, all while keeping the rest of the app in pure native code.
So we've seen how web developers can literally recycle their skills to render true native UI components across multiple platforms simultaneously, completely avoiding those clunky web views of the past. So I want to leave you with a bit of a provocative question to chew on. With frameworks like React Native allowing single code bases to deliver true, seamless native experiences, will pure native coding in Java and Objective-C eventually become a thing of the past? It certainly makes you think back to Atwood's law from the very beginning of our explainer, right? If it can be written in JavaScript, it eventually will be. Thank you so much for joining me to explore the fascinating mechanics of React Native today.